Okay, it's been a while since I got back to this project. This RV that I picked up cheap because it's gutted. But what I'm going to do today is I'm going to try and get that air conditioning unit off the roof. A couple of reasons for that. I may want to use it somewhere else. And I just want the weight off the roof. It's quite heavy. Okay, so a little bit of an update here. This is, as you know, how I explained this before, there was a tree that had fallen on this. This is the reason that this whole RV got stripped in the first place. They built this weird roof on it. Anyway, the tree fell onto it here. It bent the frame. So since I've got it, what I've done is I've cut all the floor out of it. Cut all the floor that was left. It was all mush. It was moldy. So get rid of all that. I got these tanks dumped out. Gray water and the black water tank dumped out. And I've moved the trailer around here to a little more of an open spot. And you can see here, this is where the frame got bent when the tree fell on it. It pushed down. I guess there must have been a rock or something under here that it got pushed down onto. And so one of my jobs is going to be to straighten this frame. And I'm just going to try and get all the weight I can off the roof before I start that. So what I'm about to do here, I'll show you, is the so the AC still bolted onto the ceiling here, so I'm going to unbolt it from down here and then get up on the roof and see what it takes to lift that off there. Kind of surprised if this was working that they didn't strip it out when they took everything else out of it. Anyway, let's just get this cover off here. Yeah. Of course, they took the whenever they stripped out the RV, they took the inside piece for this, the ceiling flange and the controls, but that's not the biggest obstacle in the world. If they're available, they're not that much actually. Even you can get them secondhand. But just gonna see, like I say, I'm gonna take it out, put it on the bench, and test it, see if it runs. And I could do that in here, but I want it off the roof anyway. Okay. Okay. Got that. Opened it up with a flat screwdriver. There's the shrouds. Now, there's a washer in here. Now, I'll see how I can sling this to get that down off the roof. Probably 60 pounds. Look at that. That's good. That came down just as I planned it. Yeah. Yeah, that came down pretty slick. Yeah. And like I say, I'll just bent that a little bit there. That's nothing at all, just that little bend right there. I can straighten that out. Yeah, there it is on the ground. Okay, I got the AC unit on the bench. Got some wires hooked to it, as you can see. I'll tell you that I was successful in getting it to run on the bench. It took me some time to figure out the wiring, and I've got it figured out. I made a little sketch to help simplify that explanation. Up here at the top of my drawing, right here, I've shown fan and compressor, so basically it represents the whole thing. There's several wires that come out of this and go down to a control panel up inside of here, and that's these wires right here. They all go down and then they come up and they plug into this control panel. So how this works is 115 volts comes in, it's into this control panel, and it sits waiting, ready to either power the compressor or the fan, okay, on high or low. And the control is done by the 12 volt system that would normally be done through the wall thermostat. But in this case, I just hooked it up bypassing the thermostat. And so basically this is the heart of the whole thing right here, is this is how it gets controlled. 115 volt AC comes in, so that's the plug here, that's this white wire going in under. And these other wires, the colored wires that are coming out from under it, are wires that would go to your thermostat, your wall thermostat, okay? And so I've looked online and I did a lot of research, and I figured out how they all hook up and the color coding for them. And so in essence, there's two systems. There's a 120 volt system that powers the compressor and the fan. And there's a 12 volt system that powers the control circuitry. I've got AC available. I've got the fan on low wire hooked up and the compressor hooked up to battery positive, and I have battery negative hooked up. Okay, so this, when I turn on the transformer, what will happen is 12 volts, or just a little, like I say, a little over 12 volts, will go down to this circuitry into this control panel, and it'll energize the circuit that will both start the fan and the compressor. Okay, so before I do that, just to explain, if you were in your RV and you had your RV, of course, hooked up to 12 volts to your thermostat, as this wiring diagram illustrates, you move your thermostat to a cool position, you know, cooler than the room, and you're going to basically activate the thermostat. That's going to activate this control circuitry to start the fan and the compressor. Okay, so here we go. Let's see how it goes. There we go. Fan going, compressor's running, and I know that there's no fan under here. There's a fan up in the box, but I can put my hand up. I know that I can look under there, see there's no fan, and I can feel already ice cold air coming out of the discharge. So that's working perfectly. Now, if I wanted to run the other fan, oh, that turns it all off because I've just de-energized the whole circuit. If I wanted to run if I wanted to just test this, I can run the fan on high. It's the green wire. So there's the fan running on high. Okay, and here's the fan running on low, gray wire. Battery positive. And the compressor itself. And there it is. And we'll get the fan, probably put the fan on low, the gray wire. You can add that to it. And there it is. That is blowing ice cold. It's about, it's maybe about 70 degrees here today, Fahrenheit, and this is blowing a good I don't know. I don't have a thermometer right here, but that feels like it's blowing 40, something like that. It's blowing real cold. Well, I hope that helps somebody. My drawing, it may not be perfectly clear to everybody, but I'll just explain a couple other features. There's, in this control circuit, there's also 2 terminals, and it's marked freeze. So basically what it is 2 little wires that come up, and there's a temperature probe that sticks into the evaporator. It's just so you don't want to create an icing condition in the evaporator. So there's a temperature sensor probe that's connected here to the control circuitry as well. And I'm assuming that what will happen is if it gets too cold, it'll de-energize the circuit up here. And so we've got, in this particular thermostat wiring, it would be the gray for fan low, the green for fan high, the yellow to control the compressor. Blue actually coming out of here turns into white, which is battery negative, B negative on the control circuit, battery ground, and the red is battery positive coming into the thermostat, and the white, of course, like I just said, goes out to the furnace. And that's that. Hopefully that helps somebody. I'm really glad to get this going. It's this was on the roof of that salvaged RV, and I wasn't sure if they left it on there because it didn't work or had lost its charge. I wasn't sure at all. I had no way to test it other than this, because I mean, like I say, all the components and all the wiring, everything's stripped out of the inside there. So this looks like it's a go. The only thing with this, if there's a downside, is that it's charged with R22, and R22 is a chlorofluorocarbon, which is eliminated from manufacturing as of this year, as of 2020. So, you know, it's ozone depleting. So if this leaked out, it's got ozone depleting characteristics in the refrigerant. But the good news on that side is that there is a drop-in refrigerant, a replacement for R22, and it eludes me right now what it is. I'll put it here in the video in a second. But there is a drop-in refrigerant if you wanted to maintain this, if I wanted to, use this somewhere and keep it going. I mean, it's legal to use the way it is with R22 in it. But if it leaks out and it loses its charge and has to be recharged, against the law now to recharge it with R22. So, but like I said, there's a drop-in refrigerant you can put in, and it'll work very similarly. Okay, hopefully this helps somebody. This was fun to do, actually. I enjoyed looking up the information, figuring it out, writing it down, making a sketch, and of course putting it to practice here, testing it. If you wonder what I had this cover off for, there's a little cover that goes here. I just wanted to see how everything was configured, and there's not much going on in here for wiring other than 2 capacitors. There's a start capacitor right here, the big one for the compressor, and there's a little one here for the motor, for the fan over here, the fan motor. So the capacitors are right here. And that's pretty much all that's in there. There was a real big nest of spider webs in there. I should have taken a picture of that when I opened it up. It was just plugged. Okay. Hopefully that helps somebody. Thanks for watching. Comment, thumbs up, subscribe, and we'll see you again soon. Take care.